Well, we got our snow day, so we're going to do a little bit of polynomial graph sketching via video. First thing you want to do is find your x-intercepts. So set your polynomial equal to 0 and figure out what makes each of your factors equal to 0. If you have your x-intercepts, that'll give you some points on your graph that are kind of important key points to start with. So if you set this one equal to 0, you get 3 x-intercepts, 0, 3, and -2. So I'm going to plot them. Now I need some points in between those x-intercepts because I don't know what my graph looks like until I have more points. So pick an x value in between each of those x-intercepts. So in that first section, I'm going to pick -1. In that second section, I'm going to go with +1. If you plug those into your original polynomial and just do a little bit of simplifying, you're going to get a couple more points that you can plot on your graph. And these graphs aren't going to be perfect. They're really just going to be a rough estimate for the shape of our graph. But that's okay. We're just looking at how the equation relates and kind of the key features. So it's not going to be perfect. You might have to use whatever scale is appropriate for the y values that you get. So if I plot those, I am going to have a good starting point for my graph. I hate connecting them. Those don't have to be like the high or low points. Your graph just goes through them. And the last thing, you could plug in more points on either side, but I think it's easier just to do the end behavior. So if you think about your highest degree terms, you'd have 2x times x times x. So overall, if you multiplied it out, it'd be 2x cubed. So left end down and right end up. Another one, just for some more practice. Again, start with your x-intercepts. Plot them. Pick some additional points in between your x-intercepts. So you just need 1 point in each section. So I'll go with -1 between those left two and +1 between the right two. Don't pick a fraction unless you just absolutely have to. So if you plug those values in and do some simplifying, multiply, you get -12. And then plug +1 in. You can come up with -16. So I'm going to count by 4s, I think. If you plot those, both of those are down below your x-axis. Oh, that's a bad spot. Hang on, that's better. And then you can connect it. Oh, and we'll try again. There we go. Use your end behavior again, or plug in a point that's smaller than -3 and bigger than +2. That'd be x squared times x. That second factor, or the third factor of x plus 3 has a multiplicity of 2. So really, if I multiplied it out, it'd be x to the 5th overall. Odd degree, opposite directions, positive leading coefficient. This one is not in factored form, which means to get your x-intercepts, you're going to have to put it in factored form, and you're going to have to do a little bit of guessing to figure out what those factors would be. So remember, your possible zeros are your factors of your constant over the factors of your leading coefficient. So your factors of 8 over your factors of 1, which gives you 8 possibilities. So take your best guess. Hope that your guess is good. I'm going to do 1. And yes, I cheated and made sure 1 worked before I recorded this video. So if you do that synthetic division, you end up with x squared plus 6x plus 8, which you can factor into x plus 4 and x plus 2, and then your original factor of x minus 1. Now that it's in factored form, you can get your x-intercepts by setting those equal to 0. And I'm actually going to tell you another way. Besides plugging in additional points, you could use your multiplicity of your factors. to determine whether your graph like crosses or just touches at those x-intercepts. It won't be quite as accurate, but it'll still give you a decent, reasonable shape, so I'm okay if you do this. All of our multiplicities for these zeros are odd because every factor is to the first power. So it's gonna just cross at every single x-intercept. It's not gonna like touch any of them and bounce back. It's gonna cross. So if I put that together with my end behavior, I actually don't need to plug any points between my x-intercepts because it'll be enough to know my shape. So it was x cubed, means, again, same in behavior, down on the left, up on the right. And then I know it crosses through each of those, so I could just do a little connect and my graph looks like that. Not quite as accurate as plugging in x values, but still okay. So have fun.